So now today, good day everyone. I'm going to discuss the chapter 8 of experimental psychology, which is titled Solving Problems Controlling Extraneous Variables. So now let's gonna discuss the review and study questions. We have like 12 questions to clarify this chapter. So now we have question number 1. What are the physical variables in an experiment? So I have listed here 10 physical variables that could probably occur in an experiment. The room, temperature, lighting, location, number of people, time, weather, pressure, speed, and humidity. That's all I've listed, but in an actual experiment, this can have like more than 10 physical variables. There's a lot of variables in our surroundings that could be found in an experiment. Like maybe also noise. Noise. Background noises, that could also be a physical variable. And now question number 2. How is elimination used as a control procedure? Give 2 examples of variables that could be controlled by elimination. So, elimination is used as a control procedure by removing unwanted variables that could interfere with the results. So, elimination is used when you remove the unwanted variable so that it could not interfere with your result, or it could not confound the experiment. So 2 examples are background noise and lighting. So background noise, you can remove or you can eliminate the background noise in your study by using a soundproof room. And your lighting, and maybe a photosynthesis experiment, you may eliminate other light sources by doing the experiment in a dark environment and only remaining the test lights. Number 3, what is constancy of conditions? Give 2 examples of variables that could be controlled through constancy of conditions. So, constancy of conditions means keeping certain variables the same throughout an experiment so they don't affect the outcome. Instead of eliminating the variable, you allow it to be present but make sure it stays unchanged during the entire experiment. So, 2 examples here is the room temperature and lighting. So, maybe you could keep it constant, the room temperature in a chemical reaction experiment. You can keep it constant so that it would not interfere with the outcome, or it would not confound the experiment. And also the lighting in a plant growth experiment, if you're testing different fertilizers, then maybe you can make the lighting constant so that it can actually see that all the effect of experiment is solely by the independent variable, which is the fertilizer, or the use of different kind of fertilizers on plant growth. So now we have question number 4. What is balancing? Give 2 examples of variables that could be controlled through balancing. So, balancing is a control procedure where you distribute the effects of an unwanted variable equally across all experimental groups. So, 2 examples here is participants' age in a psychology experiment. If you are testing 2 teaching methods, you make sure both groups have a similar range or an average age of participants. And number 2, gender in a medical study. If you're studying a new medication, you balance the number of males and females in each treatment group so that gender differences don't bias the results. Number 5, we have a situation here. You are doing an experiment in a local school. Because of the way things are scheduled, you can have one small testing room in the morning and another much larger testing room in the afternoon. If you have 2 treatment conditions A and B, how can you assign subjects to the testing room so that the type of room will not lead to confounding in your experiment? So, okay, to prevent the type of room from confounding the experiment, you should balance the assignment of subjects across both rooms for both treatment conditions A and B. Both treatment conditions A and B should be tested in both rooms. So, it could be like this. Morning or the small room, you could have half of the subjects from the treatment condition A and half of the subjects from the treatment condition B. So in the afternoon, in a larger room, you could also have a half of your subjects from treatment condition A and half of the subjects from the treatment condition B. So that's how it goes. Number 6, what are demand characteristics? How do they affect our data? How can they be controlled? Demand characteristics are cues or signals in an experiment that unintentionally tell participants what the researchers expects or wants them to do. Participants might change their behavior either to try to please the researcher or sabotage the study, or just act differently because they think they know the purpose. So, demand characteristics can cause biased results, can make it harder to know if the independent variable actually caused the changes, or can invalidate or weaken the conclusion. They can be controlled through deception or use of blind procedure like single blind or double blind, or standardized instructions and post-experiment questions. So question number 7, we have here a situation. A researcher says, I want my experiment to be successful. I'm sure my hypotheses were correct, so I'll just give my subjects a couple of hints here and there, maybe a wink now and then if they give us a good answer. That way, I'll really be able to show that my independent variable had an effect. So how would you convince her that her plan is faulty? What is a double-blind experiment? Would you recommend that she use it? Why or why not? So, I would tell her that giving hints creates demand characteristics and that can alter the results, leading for the experiment to be biased and scientifically invalid. So, a double-blind experiment means that neither the participant nor the experimenters, which group, treatment, or control the participant is in during the study. This prevents accidental hints, biases, or expectations from influencing the participant's behavior or the way the experimenter treats them. And yes, I would totally recommend it to her. It would protect the study from experimenter bias, more credible and scientific results, and would make sure that any effects are solely due to the independent variable and not by hints and winks. So now we have question number 8. Dr. L is planning a large-scale learning experiment. He would like to have 100 rats in one treatment group and another 100 on the other group. Because he needs so many rats, he says, well, I can't test all these animals by myself. I asked Dr. P to help me. He can run the animals in the one group while I'll test the animals in the other group. Is Dr. L's solution a good one? Why or why not? Give a better plan. So, Dr. L's solution is not a good one. This would introduce a major confounding variable, the identity and the behavior of the experimenter. This could lead to experimenter bias, confounding variable, and reduced internal validity. Better solution is to use the balancing procedure by randomly assigning the rats from both groups to each experimenter. This way, any experimenter-related differences are balanced across treatment groups, helping ensure that only the treatment variable is responsible for observed differences. So, now we have question number 9. When should a cover story be used? When shouldn't one be used? Discuss the ethical problem raised by the use of cover stories. A cover story is a false or misleading explanation given to participants about the true purpose of a study, often used to prevent them from altering their behavior and thus preserve the validity of results. So, a cover story should be used when, number 1, revealing the true purpose would bias behavior or could lead to demand characteristics. And number 2, when deception is necessary to test hypothesis naturally. Number 3, when there is no reasonable non-deceptive alternative. So, and cover story should not be used when the study can be done without deception and still yield valid results. So, it cannot be used if the study can could be done without deception. Yeah, if it's possible that it could be done without deception, then you shouldn't use deception. And number 2, when it causes unnecessary distress, confusion, or harm. And number 3, if it violates institutional ethical guidelines. So ethical problems that cover story could cause is violation of informed consent, potential harm or mistrust, risk to researcher credibility, and debriefing challenges. Why is it important that the experimenter behave in the same way toward all the subjects in the experiment? What precautions can be taken to ensure that the experimenter does this? If the experimenter changes how they act, it can mess the experiment. So being consistent helps keep the results honest and reliable. So precautions: use a script, practice beforehand, stay neutral, and you could also do blind testing. And number 11, we have, in what ways are volunteer subjects differ from non-volunteers? What difference does it make? So volunteer subjects are often more interested, outgoing, comfortable with research than non-volunteers. This can lead to biased results because the finding might not apply to the general population. Researchers need to be aware of this. So we have the last question, we have number 12, the last one. Think of 2 things an experimenter could do to avoid fatigue effects during the experiment. So now we have number 1, you can give breaks between tasks, and number 2, shorten or space out sessions. So that's all we have for our review and study questions for the chapter 8, solving problems controlling extraneous variables. Thank you.